Okay. So we're going to solve by substitution first. There's really 4 rules that we're going to talk about. I did push record, good. 4 rules we're going to talk about when we're solving by substitution. The first one is we're going to choose one of the equations and solve for one of the variables. So basically we're going to say solve one of the equations for one of the variables. So I'm going to just write down the, oh, I'm so sorry. I'm going to write down the steps right now. And then once we get a problem, I'll explain them a little bit more in depth as we get to the problems. Is that okay? Awesome. Thanks, guys. Step 2 says substitute. So then once I get an answer for the whichever equation I chose for, I'm going to substitute the answer into the other equation. Okay. And then I'm going to get an answer from that one. So, okay. So I'm going to get an answer. A numeric answer for this one. So step 1 will probably not be a numeric answer. It'll probably be an algebraic answer like 3x plus y or something, 3x plus 1 or something. So I'm going to either solve for x or y, and then I'm going to substitute that into the other equation. And then I'll only have one variable. Then you solve for that variable. And then step 3, we're going to substitute again. That answer back into the first equation. And then the last step is always the same, which is check your solution. If you actually do this last step, then you'll know whether your answer that you got is right or wrong, no matter what. So if you actually check your solution, you'll know whether you got it right or wrong. Okay, I'll give you just a few more minutes to finish writing down, and then we'll move on. Please make sure that if you have any questions today, you're asking them, okay? Okay, so I have a couple problems here. And it says just solve. So I want to, basically what I want to do is solve for whatever variables are in there. So for problem 1, I have x and y. So I want to find out what x equals and what y equals. And when I answer it, I'm just going to put this real up here. Answers are in ordered pair form. Okay, right? So some answer X and some answer Y, or AB or RS or whatever it is, and it's alphabetical, okay? So that's the form that the answers need to be in. I can't even talk. So step 1 says I'm going to take one of the equations, either equation A or equation B, it doesn't matter. Just choose one of the equations. Okay, so I'm going to choose one of my equations, either A or B, and solve for one of the variables. Now, if I look at equation B is already solved for X, which is beautiful. And some of them will be done that way, so great. Some of them won't be. Just so you know, some of them won't be already solved, and you'll have to do that. And there's examples of this coming up. So this one's already solved for x. So step 1 is already done. And then it says, step 2 says, take that equation, and I'm going to take this equation, and wherever there's an x in my other equation, I'm going to substitute that in for x, because it says x equals 2y minus 1. So wherever there's an x in my other equation, I'm going to substitute in 2y minus 1. So I get, in equation A, I'm going to do 3y plus x, but now my x, because it says so right here that x equals 2y minus 1, wherever there's an x, I'm going to put 2y minus 1. So 2y minus 1 equals 4. And now I just have one variable left in this equation, and I can solve for y and know what y equals. So add 1 to both sides, and I get 5y equals 5. Divide by 5, and y equals 1. So in my ordered pair part of my answer, y is 1. Okay, and then step 3 says I'm going to take this answer, and I'm going to plug it back into my original equation, or my other equation. So I'm going to plug that back in to find out what x equals, because I have to know what both y and x equal. So this tells me that x equals 2y minus 1. So wherever there's a y, I'm going to put a 1. So this becomes 2 times 1 minus 1, which is 2 minus 1, or 1. So x is 1, y is 1. Make sure you're asking questions if you need it, okay? So we're going to do the next one. We're going to do exactly the same thing. We have to do a little bit more to number 2, and that's usually what happens. We have to do a little bit more to it. So in part A, I'm going to just call them A and B again. So it doesn't matter which equation I choose. I'm going to choose, I have an A by itself that doesn't have any coefficient with it. So that's the first thing I'm going to look for, is if I have a variable that has no coefficient, then I'm probably going to choose that equation and solve for that variable. So I'm going to choose equation A and solve for A. So A minus 2B equals 3. So if I add 2B to both sides, I get A equals 2B plus 3. Okay? So now I'm going to take that equation for A and substitute this 2B plus 3 back into equation B. So now I'm going to go into equation B. And equation B says 3A equals 6B plus 9. So wherever there's an A, I'm going to take this and I'm going to put it in there, because A equals 2B plus 3. So I've got 3 times 2B plus 3 equals 6B plus 9. So I've got 6B plus 9 equaling 6B plus 9. Ooh, subtract 6B, subtract 9, and I get 0 equals 0. What kind of solution is that? Oh, we haven't talked about that actually. We kind of did. We said it's an identity when I'm just solving for one variable. That was like our very first lesson. But when I have two equations with two unknowns, that means my answer, if I get the same thing equaling the same thing, that means my answer is all real solutions. All real numbers, sorry. All real numbers. So any number will make the equation true. Okay, so if I get the same thing equaling the same thing, it's all real numbers. Any questions? Everyone okay? Okay. So I think it's your turn. Okay, so there's two equations there, two sets. We'll just do two sets at a time. So just go ahead and put your answers in the chat box when you get them. I'm going to pause it for 5 minutes. Okay, so let's go ahead and talk about these. So luckily on A, this equation's already solved for x, so I already have one of the variables solved. So I'm just going to substitute it into my other equation. So I get 3 times x, but x is now 8 minus 4y, plus 5y equals 3. Is everyone okay with that step? Okay, so now I'm going to distribute, right? So I get 24 minus 12y plus 5y equals 3. Subtract 24 from both sides. And this is negative 7y equals negative 21. Divide by negative 7, y equals 3. And remember, we're supposed to write the answers in an ordered pair. So I should have a parentheses around them, x, y. Is everyone okay with that? Oh, Oscar's here. Okay. Okay. Now that I have this equation, I'm going to take this, y equals 3, and I'm going to plug it back in to where my equation that says x equals, because now I've solved for x, but now I need to solve for y. So now I know that x equals 8 minus 4y, but y equals 3, so I get 8 minus 4 times 3, which is 8 minus 12, or negative 4. So x equals negative 4. So I'd write my answer like that. It's an ordered pair. Okay? Questions? Awesome. Okay, if I go to the second set, again, my first equation is already solved for y, so I don't have to do anything. Yay. So I'm just going to substitute in my second equation, wherever there's a y, I'm going to put negative 5x plus 17. So I get negative 6x minus 5 times negative 5x plus 17 equals 10. Okay. So negative 6x, distribute, plus 25x minus 85 equals 10. So add 85 to both sides. And I get 19x equals 95. Divide by 19, x equals 5. So I'm going to take this equation, x equals 5, not equation, this answer, and plug it back into this equation so I can solve for y. So I get y equals negative 5x plus 17. So wherever there's an x, I'm going to put a 5. So I get negative 5 times 5, and that should have been a 17, not a 15. Let's try that again. Plus 17, okay, equals negative 25 plus 17, which I think is negative 8. So my answer for this would be 5, negative 8. Okay? Questions? Everyone okay? All right. So we've got 2 more for you to work on. Do you need like a minute or so longer than 5 minutes? Is 5 minutes not quite enough time? Anybody? Or is that okay? Just a little bit longer? No? Yes? Maybe so? Okay. You guys are not talking to me today. Okay. So this time, none of my equations are solved for any of the variables. But if I look at this one, part C, I have a positive x here. Oh, shoot. Sorry. I have a positive x here, so I would probably solve for that. I would probably take the second equation and solve for that x. I mean, I could take the first equation and solve for the negative x and then have to divide by a -1. It's okay, I could do that. But I think I'll take the second equation. So I'm going to take A and B. I'm going to take equation B, which is x plus 3y equals 12, and I'm going to solve for x, so subtract 3y. So I get x equals 12 minus 3y. It's okay that I wrote it that way, doesn't matter. Okay, so then I'm going to take this and I'm going to substitute it into my other equation. Okay, so my equation A says negative x, but x is now 12 minus 3y minus 4y equals -14. So this is the important part. If you did not, whether you wrote this, and I guess I should say this, whether you wrote it as 12 minus 3y or -3y plus 12, it doesn't matter. I have to make sure that I distribute this negative through the whole thing, this negative right here. Okay, if you forgot that negative, your answer is going to be incorrect. So make sure you distribute that through the whole parenthesis. So I get -12 plus 3y minus 4y equals -14. Okay, so now I'm going to add 12 to, I hope this is answering your question. So I'm going to add 12 to both sides. So 3y minus 4y is -1y equals -2. Then I'm going to divide by -1. So y equals +2. Okay? And then I'm going to take this +2 and I'm going to plug it back into this equation. So I get x equals 12 minus 3y, which is 12 times minus 3 times 2, or 12 minus 6, which is 6. So x is 6 and y is 2. Okay, so I'm not sure that anybody who put in, oh yeah, Jalen did. Great. I was going to say everybody else I think that put in an answer is slightly wrong. So please make sure that you know what happened on this problem. But I'm thinking, I haven't done it to without the negative, but I'm thinking it has something to do with the negative sign here. And that's where most of the issues have come in. So I hope that's okay. We're going to go ahead and go on to the second problem here. So in this equation, in this set of equations, I only have one variable that's by itself, and it's the y. So I'm going to take equation B again, and I'm going to take equation B, and I'm going to solve for y. So add 3x. So I get y equals 3x minus 9. And I'm going to take that and I'm going to plug it into there. So I get in equation A is 4 times x, okay, great, minus 4 times y, which is 3x minus 9 equals -4. Distribute. So I get 4x minus 12x plus 36 equals -4. So subtract 36, and I get -8x equals -40. Divide by -8, x equals 5. And I'm going to take that 5 and plug it back into this equation up here, right there, to find out what y equals. And then I know that y equals 3 times 5 minus 9, which is 15 minus 9, or 6. So the answer for this one is going to be 5, 6. Questions? Is everyone okay with that? Okay. I think that, okay, great. Okay, so now we're moving on from substitution to one that I think is sometimes easier and sometimes harder. I know, kind of bad to say it both ways. In some equations, in some sets of equations that give me, this is so much easier. But in some sets, it's so not easier. So than substitution. That's why they always teach substitution first. So we're gonna talk about solving by elimination now instead of substitution. And honestly, when you're solving these, I really don't care how you solve them. I don't care which method you use, as long as you get the correct answer. Does that make sense? And when I'm checkpointing you, honestly, I think it does say solve by substitution or solve by elimination, but I don't know how you're solving it. So choose which method you like best and stick with that. Sometimes it's hard to use substitution because you can't get a variable by itself, and you don't want to work with fractions. So elimination is better, and sometimes elimination is better than substitution. So just choose which one you like the best, basically, and then but be able to use both of them. So the steps for using elimination, the first step we don't always have to do, but it is arrange the equations with like terms in columns. I think that's spelled right. Yeah, okay. And then step 1 and 2, I don't always have to do. Those are the two that sometimes I have to do and sometimes I don't. So step 2 is multiply if necessary, or if needed. That's an easier word to spell. If needed. Okay. And then step 3 says add. And I'm going to say or sometimes. Let's just not put or in there. Let's just do it in parentheses. Add, and sometimes we subtract the equations together. Okay, so I'm just going to add the equations together. Step 4, substitute. Substitute. Because once I add, the whole thing by elimination is once I add the equations together, I get rid of one of the variables, and I'm left with just one either x or y left, and I solve for that, and then I get my answer. I substitute it back in to get the other one. Okay, and of course the last one is check, which I did not do at all. Check the solution. And I'll talk about that this time so you guys know how to do it. It's really easy. Okay? So, are we ready? You guys ready for this? Do we need a second more to write this down? Okay. So I have two sets again, just like before. I'm going to kind of blow them up a little bit. So what it means by arranging my like terms in columns, as you can see, my x's are right here in a column. My y's are here in a column, and my constants are here in a column. And that's what step 1 means. So arrange them so they're all in columns with each other. And then multiply if necessary. And this is the one I'm going to kind of look at. So if I have two coefficients are the numbers in front of the variables, that are the same. So look, I have a 2y, yeah, I can do that. I have a 2y and I have a 2y. And see, notice that I have two 2y's. Great. Awesome. I don't have to do anything. I don't have to multiply. If I have each one of the variables, it doesn't matter if it's x or y, and the coefficients are the same, I don't have to do any multiplying, okay? So the third step says add them together or subtract. And how do I know if I'm going to add or subtract? Well, this is how you tell. If I'm going to look at these two right here, okay? The ones that are the same. So if one's negative and one's positive, I'm going to add them together. If they're both the same sign, so if they're both negative or if they're both positive, I'm going to subtract them, okay? Because the whole goal is to make the y's, the ones that are the same, go away and equal 0. So right now, 2 minus 2 is 0, so I don't have to do anything. I'm just going to add them together. So I'm going to add everything together. So I'm going to add this together. So x plus 3x is 4x, okay? Negative 2y plus 2y is 0. Equals 28. 28, okay? And then I'm going to divide by 4, and x equals 7. Beautiful. In my ordered pair, I already know that x equals 7, okay? Then it says substitute. So I'm going to substitute this back in. Sorry, I'm going to try and erase this a little bit. There we go. So I can see what we're doing. I'm going to pick one of the equations. It doesn't matter. Again, it doesn't matter if it's A or B on this one. Just pick one of them and substitute it back in. I think I'm going to choose the one with the x by itself, so I'm going to substitute back into this one just because I don't have to multiply x by anything. That's the only reason. So I've got 7 minus 2y equals 11. Then I'm going to solve for y. So subtract 7, negative 2y equals 4, divide by negative 2, and y equals negative 2. There we go. Done. Okay, we're going to do the same thing on the next problem. Okay, if I look at my variables, they're arranged in columns, okay? Awesome. The problem is none of them have the same number. But if I take this second equation and I multiply 5 by 2, I'm going to get 10, right? So I'm going to take, that's why the multiply if necessary is there. So I'm going to take my second equation here. And I always like to have where I have to add. So I'm going to multiply by negative 2 because 10 minus 10 is 0, right? Does that make sense? So I'm going to multiply by negative 2 to hit 2 all the way through. So that gives me negative 10a minus 6b equals negative 4. Is that right? Yeah. So all I did is write an equivalent equation. It's the same equation. I just took it and multiplied by negative 2. It's the same equation. And then I'm going to take my original equation, my first equation, equation A, I guess, and write it down. And I'm going to add the equations together. So 10a minus 10a is 0. Negative 6b plus 6b is 0. So this side is 0. And this side is 4. Does 0 equal 4? No. So this answer is no solution. Doesn't matter what value I put in for A or B, I will not get an answer. Okay, is there any questions on that? Are we okay? Are you guys ready to try it? Okay. So, same thing as last time. So here we go. I'm going to go ahead and do these two problems, and then you'll do the last two, and then we'll work on homework, okay? So the nice thing about this one is that I've got two of the same variable right here. So I've got, and they're opposite, so I've got -6 and +6. So all I'm going to do is add the two equations together. So -6 plus 6 makes a 0. Yeah, Jalen, good. And then this is -9y equals -36. Divide by -9, and y equals 4. So y is equaling 4. It doesn't matter which equation I plug it back into. So I think I'm going to plug it into the second equation just because I'm multiplying by 3 instead of 4. That's the only reason. So I've got 6x minus 3 times 4 equals -18. So 6x minus 12 equals -18. Add 12. 6x equals -6. So x equals -1. By the way, how you check this is so easy. I just want to talk about it really quick. I have an equation here, and I have an x and y value. I plug x in, I plug y in, and see if it equals -18. That's it. That's how you check it. Okay, to make sure that it's right. That's it. Okay. So for the second equation, I took the first equation, and I said, now this is another decision you get to make. Okay. Do I want to get rid of my x's, or do I want to get rid of my y's? Okay. So I decided to get rid of my x's because I only have to multiply by one thing. Okay. I only have to multiply one of the equations. If I decide to get rid of my y's, I have to multiply both equations. So I'm just going to write that out like really quick. I'm not going to do the whole thing, but I'm just going to show you what I would do. If I decided to get rid of the y's, I would take this top equation and multiply it by 4, and I would take this bottom equation and multiply it by 3, because 4 times -3 gives me -12, and 4 times 3 gives me +12, and so my y's would be the same. So you can multiply both equations if you need to, just so you know that. However, on this particular equation, I notice that 5 is a multiple of 15, so I'm just going to take this top equation and multiply by -3, because then I only have to multiply once. I'm only changing the equation one time. One equation. I'm only changing one equation, sorry. So -3 times 5 is -15x, and -3 times -3y is +9y, and -17 times -3 is 51. So then I get 13y equals 52, divide by 13, and y equals 4. Okay, now I'm going to substitute back in. Just choose one of the equations. It does not matter which one. So I might as well just choose the second one. I don't know why. Why not? 15x plus 4 times 4 equals 1. So 15x plus 16 equals 1. Subtract 16. 15x equals -15. Divide by 15. So x equals -1. So my solution is -1. Oops, that is not a -1. -1, 4 again. Okay. Yeah, no, okay. Okay. And then the last two equations. So for the last two problems, On this one, I chose, notice none of them are multiples of each other. So I chose to get rid of the x's because multiplying by 2 and 5 is better than multiplying by 7 and 8. Are you okay with that? Does that make sense? So if I got rid of the x's, I have to multiply by 5 and 2. But if I got rid of the y's, I'd multiply by 7 and 8. So which ones would you rather multiply by, 5 or 2 or 7 and 8? Right? That's your decision. It doesn't matter which one. If you like to multiply by 7 and 8, awesome. I just like to multiply by the easier numbers. So I chose to multiply and get rid of my x's first. I hope that's okay. I hope that makes sense. So I'm going to multiply this number by 2, and this one, I think I multiplied by -5. Oh, no, I multiplied the top by -2. It doesn't matter. And the bottom by 5. It doesn't matter. So, okay, so -2 times 5 is -10x, and -2 times -7 is 14y, and -2 times -16 is 32. And then 2 times 5 is 10x, and 8 times 5 is 40y, and 26 times 5 is 130. Add them together, and I get 54y equals 162. Divide by 54, y equals 3. Okay? And then pick an equation, plug it back into it. It doesn't matter which one. I'm going to choose the second one. So 2x plus 8 times 3 equals 26. 2x plus 24 equals 26. Subtract 24. Oh, come on, stay up there. Thanks. Subtract 24. And 2x equals -2. So x is going to equal -1. So we've got -1 and 3. Okay, questions? Is everyone okay? No one's saying anything today. Okay. The second one, or part D, again, I'm going to use the same type of reasoning. I can to get rid of my x's, I'd multiply by 9 and 7. And to get rid of my y's, I'd multiply by 4 and 7. So I'm going to get rid of my y's this time. So I'm going to multiply the top equation by -4 and the bottom equation by 7. And I could have multiplied by 4 and -7. It just doesn't matter. It does not matter, okay? The only difference is going to be the signs of my numbers when I get done. So -4 times 9 is -36x minus 28y equals -36. And then I've got 49x plus 28y. Oh, that's an 8 and a y are backwards. 28y equals 49. If I add them together, I get 13x equals 13. So divide by 13. X equals 1. Plug it back into one of the equations. I get 7 times 1 plus 4y equals 7. Subtract 7. 4y equals 0. So y equals 0. So my answer is 1, 0. Okay. All right, so you guys have, I think it's 9 questions. Actually, I don't remember because I haven't made the lesson in a while in Delta Math. It's 9 to 12 questions on Delta Math on this. So, okay. And then when we come back from Thanksgiving break, we'll do a review on this. So, we only have like 5 minutes left in class, so